Já bych vám rád představil dalšího speakera, kterým je Michal Šimon, který má kromě svého startupu Kodeák na to, aby jsme ten kód psali dobře, tak se věnuje boje proti technickému dluhu a tak, aby jsme vlastně dávali co nejkvalitnější kód. Tahle přednáška bude zaměřena na serverless v rámci machine learningu.
And one more in English. So please welcome on the stage Michal Šimon, who will be talking about serverless machine learning. He has worked several years in Silicon Valley as a DevOps engineer, and now he helps developers fight technical debt and deliver high-quality software faster at Kodiak. Please welcome.
Thank you. Thank you. All right, I'm very passionate about this topic actually, so let's dive right into it because yeah, we don't have that much time. A little bit about me. When I finished university, I just bought a plane ticket to Silicon Valley and tried my luck to get a job in some startup. It was a great experience. I worked in a dating company. You can imagine that as a Tinder, but for specific markets. So yeah, if you need a pickup line, let me know. Right now I'm working at Kodiak. We help developers fight technical debt. So yeah, I will tell you a little bit more about that later. Quick disclaimer before we start. Because we don't have that much time and I would love to dive deeper into those areas. But please take from this presentation mostly the ideas, despite the fact I will show you some implementations, a little bit of code, focus mostly on the main ideas around them, because we don't have that much room for details. Also, I will show you a little bit of, let's say, cloud terms and cloud services specifically from AWS, but don't take it for granted. This is my favorite cloud, but this doesn't mean that this cannot be replicated in any other vendor. So when I say AWS, I usually mean more cloud rather than this specific vendor. All right, are you ready? When I talk to companies sometimes, it's easy to get an impression that basically any machine learning means large language models, and the sentiment is usually that large language models will change, this is the thing, it's answer for everything. And we have multiple services that you can just simply use, call an API. You can of course use ChatGPT or specifically on AWS Bedrock, or do some of your own models on SageMaker and services like that. But I would like to focus on something else. I believe that smaller models and more specific models are usually better fit for most of scenarios, actually. And I would like to show you a few examples of that. For example, if you would like to translate something between languages, there are specific models that are smaller, faster, usually much cheaper, and you can get better accuracy if you use them instead of just large language model, which can actually deliver as well, but you just don't need the whole thing. You are much better with a single model. The same, or a simple model, sorry. The same goes with image recognition and many other categories. Not sure if this is super visible, but this is a screenshot from Hugging Face. I'm sure you all know Hugging Face. They have plenty of categories. They have plenty of well-trained models that you can simply use in your specific app or use case. And they usually can deliver much better result than just large language model. And this is basically a reason why I am having this talk, because I would like to show you a few of those. So why don't get me wrong, I love all those cloud services. If I can use them, I will. And this is usually my first choice. But it always doesn't mean it's the best choice for the job. So maybe you have very specific use case. Maybe you are dealing with some sensitive data that you don't want to just send here back and forth through an API to a third party or something like that. Maybe you have you need to run on-prem as well. This is, for example, one of our use cases. You can simply not rely only on the on those services that offers you machine learning as an API. Maybe you have some regulatory limits that you have to respect. And you can have many other reasons. There is a big room for running your own models in your apps. And yeah, you can simply leverage that very easily. And I would like to show you how. There is no one-size-fits-all, and LLMs usually feel like that. So don't get that message wrong. Please use the right tool for the right job. Okay, we have the intro. Let's dive a little bit deeper into that. So how to run an off-shelf model, for example, from Hugging Face in your app. And I would like to show you it's actually not that complicated how it feels like. This is a difficult diagram, but as you can see, the Hugging Face logo down there, I will guide you through it. We will start from the Hugging Face logo. You basically go to Hugging Face, do your research, find the right model for the job you need, read the documentation, experiment with the model, try different inputs, see how the model performs, try to understand how the model is built, why, what is the data set, who is maintaining the model, and so on. All these things are intense, but once you are done with that part, now we come into play. Usually those models are built by different machine learning frameworks, like PyTorch, or TensorFlow, or many others. And here is the secret sauce. There is an intermediate format which is called Onyx. And Onyx is, I would say, something like Java bytecode. You write Java, you compile it into bytecode, and then you can run the bytecode on many devices. This is the same for models. You write, or you create the model in your favorite framework, but then you compile it into this Onyx format, and this format allows you to deploy it to many different platforms, from the browser to like many different programming languages, or embedded devices, the cloud, on-premise, and so on. So Onyx is really the key over here, and it usually comes with several even performance benefits. How to do that? Even though if you are not maybe that familiar with Python, you need basically 3 lines of code. You need to import your favorite machine learning framework. You load the existing model, which is trained with the framework, and then you basically export it. There are many ways how you can tweak it over here, but this is just the simple version. And it usually works well. So we export your model into Onyx. We download it from Hugging Face. We export it like that into Onyx format. And for simplicity, I actually used a different programming language, in this case, JavaScript. And this is how you run the model. You basically import specific Onyx library. Onyx runtime is usually the good keyword. They have implementation for many different languages, so choose something that you like, and you develop daily. You import the model by creating an inference session, and the inference session, it takes a little bit of time depending on the model size, how long this step will take. So you have to load the model in the memory, and then you just define what is your input, and then basically you run the inference and get your results. It's actually like simple. There you can tweak a lot of this, but in essence, this is the main part. And let me show you actually a quick demo. So because of the conference, I was looking for something visual, so I use YOLO. Oh, okay, we need to switch. That's okay. So I use YOLO. I use YOLO version 8 and used AWS Lambda for running this code. Lambda is very good for running like small, quick jobs that you have to pay only for. Perfect, thanks. You pay only for the resources you really spend, and it's actually great to just use for one-off tasks like this. I can load a custom file, but I have a picture prepared. So basically, this is from Street View, a picture where somewhere over here, over the campus, and this is how the YOLO predicted what is on the picture. I haven't done any training, anything specific, but I was able to quickly take an existing model and deploy it into my app as an API, and I can just call it and do whatever you want. This whole thing is just a HTML file which is visualizing the results, and over here I am just showing what is coming back. I will get back to it in the cloud. Sorry, in the slides. So yeah, this is what you can very easily do, and yeah, we should be fine. This button, I guess. And we are at the beginning. That's okay. All right, and I have the demo as a video as well. So how the whole setup looks like? It's simple. I grab the picture, I encode it into base 64, send it over the wire to the Lambda. The Lambda runs the model, does the computation, and sends back in a JSON format all the results. So it's positions of the objects, probability, how accurate the model thinks the object is what it is, and of course some bounding box coordinates. Just for a quick comparison, there is an AWS service called Recognition, which can do exactly the same thing. Maybe you are asking why you just don't use Recognition. Yes, sure, this is definitely a valid option. If we compare the pricing, for example, for $1 spent on both of those implementations in AWS Recognition, you can get analyzed around 1,000 pictures for $1. If we compare that with this implementation with Lambda, you can do 60,000 pictures for the same money. There are ways how to optimize both of those solutions. There are ways how to, like, they differentiate, they have some special features. The YOLO has its own things. This is not like apple-to-apple comparison, but just to give you a little idea, you can actually save a lot of money if this is if your use case fits this scenario. So what you saw is basically this image was analyzed. It took around a second usually. Not sure about the Wi-Fi over here, but this is usually what I got as a result. And this is an example of what you get from the API back. The front end just gets these results and draw the lines in the picture. Why is it good for? What is it good for? There are plenty of things, but I would mention one that can be handy maybe for you. Maybe you have some e-commerce site, or you have some website which has a lot of pictures, and you would like to improve your SEO by tagging those pictures with a good keywords. this can be very helpful, actually. And this is a great way how to generate those keywords. And maybe you can employ another model, which can just write it into sentences and just, you can work from there. So, yeah, this is how it can actually be simple to deploy an off-shelf model into your app as an API or as some background service and stuff like that. As a second example, I would like to show you how we use at Kodiak machine learning for actually already quite some time. At Kodiak, we connect to a GitHub, Bitbucket, or GitLab. We analyze every commit that you create, and we deliver those results back to you through our integrations with those services or through a dashboard where you can visualize through the time your progress. We cover plenty of languages, so yeah, there's a lot of data. But one of the features that we actually use machine learning for is called linguist. Before we can do any specific analysis, we need to understand first what all the languages do you have in a repository. And linguist is exactly this type of service. We have multiple strategies for distinguishing between those languages. We start usually from the very easy ones, like file extension, file name, shebang, and so on. But if all those strategies fail, we have a classifier, which is a machine learning model. We are able to recognize more than 450 languages, and we created basically a data set of those. It's a couple of megabytes of source code that we labeled properly and trained the model on. And this is how it looks like. We basically grab a sample from the dataset. We tell it what language it is, and this is how we train. And this goes for like all of those examples. And when we want to predict when you commit your changes into Git, we basically run this classify method, and we don't know what language it is, but based on the learning, we will get, in this case, for example, this is Java, and it knows it by 77%, which is good enough. So this is in our production for quite some time, I think like 4 years, something like that, and it works perfectly in combination actually with Lambda, because we build the whole thing in a serverless manner. So I would like to conclude why this is actually a good idea to experiment with, to like combine those two aspects of technology these days. Serverless, which can give you a lot of efficiency, a lot of lightweight and cheap compute, and a machine learning model, which can really help you differentiate your product from your competition. We have a highly specialized use case in comparison to some LLM. We need a lot of control over the model, because when a customer tells us, hey, there is something wrong, we need to adjust the data set, run the training again, and we need to tweak it very specifically. And this is usually not that easy with LLMs, because you have no idea what all came into the training, and it's tricky to adjust. It costs us fraction of the cost, and we get much better accuracy with small, dedicated model to one task. And we are able to deploy it on-prem as well, because we support this for some of our customers. So yeah, these all combined gave us the ability to leverage machine learning model in a product in very, let's say, seamless way. If you are thinking about having or employing a machine learning model in your app, I would love to talk to you. Come to me in the speaker's corner, and I would like to hear about your use cases, see if there are many, there are some combinations with technologies I showed you, or maybe you have a different strategy. I would like to learn from you and discuss what what you are planning and what can be done in this area. And because we are a company that cares about technical debt, I would like to ask you all, please leave your code always in better shape than you found it. If we all do that, we will just get rid of the technical debt eventually. Thank you very much.
Well, thank you. We have time for just one question and a short answer before we move to the speaker's corner. And the question with the most thumbs up is, please share with us your best pickup line.
Haha, this really depends, but I would maybe say the formula for it. It needs to be controversial, at least a little bit. And the example for that is, would you spend a month in the mountains or one single day in the Hogwarts school? Something like that.
Okay, thank you. So everybody who is interested in continuing the discussion in the Speaker's Corner, you know the way, as I've said many times today, through this door and still straight forward until you meet the Speaker's Corner. Thank you very much for your talk. It was a pleasure to have you here.
Thank you for having me.